My name is Ed Reiner. I'm a senior wetland scientist at the Environmental Protection Agency in Boston, Massachusetts. And the title here is Hydrological Evaluation of Tidal Restrictions at Rumney Marsh. You know we're in Saugus in Massachusetts anyway. Rumney Marsh is located about 5 miles north of Logan International Airport. About 45% of the marsh has been altered by dredging and filling since 1803. The most significant fill that I wanted to talk about anyway, we could debate what's the most significant, but is between 1967 and 1969, 6 million cubic yards of sand and gravel soils were used to fill 120 acres of Rumney Marsh to create an embankment for the planned construction of Interstate 95. Abandoned ever since, this embankment altered tidal flooding patterns in the marsh. In 1988, the designation of the marsh as an area of critical environmental concern brought significant attention to the marsh. But the I-95 fill has been eroding ever since it's been placed there, some 50 years ago. And this erosion is still continuing to this date. There's Sean. Why do we want to remove the embankment? I want to remove the embankment. It's because it would restore wetland habitat. And it's a stated goal in the 1988 designation of the Rumney Marsh area of critical environmental concern. And this fill can be used beneficially for other public works projects, including beach nourishment and dune creation as part of flood protection plans. Intertidal habitat restoration is relatively easy to do at Rumney Marsh, and it has been done with pieces of the embankment to date. Natural colonization usually works. So in this particular instance, this is the removal that occurred to mitigate the environmental impacts of the Third Harbor Tunnel and the depression of the Central Artery in Boston. So you could see on the top right how it changes over time, and Spartina, the dominant salt marsh cordgrass, came in on its own. This map is available on EPA's website. It provides details of completed and potential wetland restoration projects in Rumney Marsh. In the center of the map, the green areas depict 37 acres of completed restoration projects accomplished to date as mitigation for 5 major public works projects. All embankment removal marsh restoration projects to date have had to maintain a continuous flood protection barrier due to the belief that the embankment was reducing the tides and thereby providing flood protection to East Saugus residential and commercial property. A 120 acres of fill essentially is the footprint of this highway to nowhere. 37 acres have been removed to date, but 444 acres upstream of that embankment are restricted in terms of tidal flow. So we haven't addressed the hydrology. This is the Pines River crossing. I should say it's the relocated Pines River. And it's interesting that the permit that was issued in 1966 for this by the Corps of Engineers called it a temporary relocation. I don't know why they called it a temporary relocation. Anyway, no bridge was ever constructed because the highway was abandoned in 1972 when Governor Sargent stopped it. So ever since, we've been trying to remove it. Now, completed around 2012, the reconstruction of 3 bridges on Route 107 increased tidal flow on purpose to help control invasive species, reduce erosion, and improve recreational navigation. When you look at this bridge, if you look at the left picture, you could see how this bridge, and 2 of them were like this. This is the East Branch of the Pines River Bridge. Diamond Creek also was like this as well, where it had vertical walls. But the new bridge has slanted riprap, and that allowed for an increase in hydrology. The Pines River Bridge was also increased in size. That's the one on the left. The two that I spoke about, Diamond Creek and East Branch, essentially have a tripled length, and that increased the tidal flow by more than 50%. The Pines River Bridge also increased the capacity for tidal flows by about 28%. But it doesn't matter where you are in the estuary. You could be in East Saugus, you could be in Lynn, upstream or downstream of the embankment, and flooding happens. The water can even overtop Ballard Street, as seen here in Saugus. So I undertook a study to evaluate whether breaching the embankment to restore the formerly cut off drainage patterns would adversely affect tidal flooding of low-lying residential and commercial property. If you look at the picture on the right, that's one of the new bridges. It's hard to get under at high tide, but this bridge was increased in height so as to allow for improvements to recreational navigation. I can tell you it wasn't increased enough, but the highway department, you know, when you raise a road, you have to chase that fill. And they didn't want to have a large impact to the rest of the marsh. So the bridges are a little humped up in a sense as you go across the roadway because they didn't raise the grade of the entire roadway. Anyway, using handheld depth gauge paired with a GPS device, I was able to log or essentially gather bathymetry data, which is the depth of water below an elevation that you have to establish on the waterline. This map depicts the location of the survey that we did. The different colors represent different depths. The bottom elevations at the Interstate 95 abandoned highway crossing measured 26 feet deep on the upstream side and almost 33 feet deep on the downstream side, whereas the channel was armored with riprap at minus 9 feet. So you have these significant scour holes that have formed on both sides of the embankment, and this is the depth gauge information. And here, these are the two other bridges, the Railroad Bridge and Route 107. And the Railroad Bridge, or Route 107, measured 24 feet deep. I'm using an NAVD 88 datum on the upstream side and 38 feet deep on the downstream side. The railroad crossing, which they call Dizzy Bridge, had scour holes at 22 feet on the upstream side and almost 47 feet on the downstream side. So that's quite a deep hole. Maybe that's why they call it Dizzy Bridge. So after we did the bathymetry study, it was important to figure out water levels. So we undertook a water level study using level loggers, which are pressure transducers. These were deployed for 142 days. In order to establish the elevation of the transducers, we used a global navigation satellite system. The results of the study, well, this shows the locations where we picked locations on either side of each of the three major tidal restrictions in the marsh: the Railroad Bridge, Route 107, and the I-95 embankment. We also studied the Ballard Street salt marsh situation and the Saugus River, but I'm not going to show you the results from that. We're waiting for the town of Saugus to install some tide gauges that we could better establish the starting elevation for tidal studies. But this is the results for the 5 sites along the Pines River. And when you look at this graph, or I'll just try to explain it, that everything looks pretty close together, doesn't it? You know, and this is representing the high. We have two tides every day in New England. One of them's a little higher than the other by about 0.4 of a foot. And so this is just showing the higher of the two tides every day, graphing it at each of the locations. And what we learn out of this is that the water going through the railroad bridge is slightly diminished, very little. But the water going underneath Route 107 is slightly more diminished in terms of a tidal restriction. But it only cuts off about 0.2 of a foot of tide. And so I'm showing you a second graph because we split it up into the first 42 days of study and then an additional 90 days. And we did this for various reasons, but we wanted to independently review the two different time slots. And this is showing you something interesting that I'll try to explain to you. Okay, my cursor might show it, but in 1989, I'm shaking the table, aren't I? Sorry about that. In 1989, when the Corps of Engineers studied the hydrology, they determined that mean high water upstream of the embankment was 0.3 of a foot off from the downstream side. And they determined that mean spring high water, sort of every month's high tide, was 0.8 of a foot lower. And they determined that the maximum annual high water line that you'd expect was as much as 1.7 foot lower. But the bottom shows that in 2019, something changed. What changed? The three bridges on Route 107. And that changed things a lot because now there's almost no difference, or there is no difference between mean high water and mean higher high water tidal datums on both sides of the I-95 embankment. And the maximum observed tide in East Saugus is only about 0.2 of a foot off of the tides in the unrestricted portion of the Pines River. So this study has shown that the I-95 embankment is not providing the flood protection that people believed it was providing. Why is this important? Because it's only there because people thought it was providing flood protection. The goal of the ACEC is to remove it all. The Secretary of Environmental Affairs said anything that doesn't do it would be considered inconsistent with the goal of the ACEC. But the Corps did a study. They thought that that it was the I-95 embankment that was providing flood protection. And I'm doing this study, or I did this study, and we're going to be writing it up as a report, an EPA publication. It's going through peer review. I hope people will believe it, because this is important, because it means that we can potentially restore the marsh hydrology that's been affected for 50 years by the I-95 embankment. So Route 107 will continue to restrict tides. The Highway Department designed the bridge because they didn't want to flood people in East Saugus. Now, they didn't know, or they didn't really study it well enough. They believed the Corps studies. They thought they were only going to be improving the water flow for part of the marsh. They didn't know it would have this effect on the other side of the I-95 embankment because they believed the Corps studies. Now, I'm sorry the Corps got it wrong. I don't know how the Corps got it wrong, but they tell me they paid a lot of money to do a model. They actually had a model in Vicksburg, Mississippi, at what was used to be called Waterways Experiment Station of the estuary. And they owned this model, so they could always rerun the math or the model using the new hydrological information, the new data, the dimensions of the bridges. They could run it for themselves and determine whether it's true or not. Now this is showing you the locations in yellow of the former tidal creeks that were cut off by the I-95 embankment. And it's overlaid with a picture of what's going on out there. And you could see that certain fill removals have already been sort of situated in alignment with where we could restore the hydrology. I'll explain that a little bit more. So here again is what it looked like. Somebody asked me, can we get it to the way it used to be? Probably not. That's the way it used to be. But the road embankment modified that. So I drew up this plan to try to show what was in yellow now is in blue, showing the historical creek locations. And what's in red is a suggested removal plan in a sense. And I came up with this only because I thought it makes the most sense. It's the least amount of material to remove to potentially gain the best benefit. So instead of just restoring a creek, we could restore the sheet flow. That's what it's called, sheet flow across the salt marsh surface. Because salt marshes aren't designed that all the flow should be confined to a creek. In fact, that only happens below mean high water, sort of. Above mean high water, the marsh fills over the high marsh surface. And if it's allowed to flow freely like it historically was, it would be better for the marsh, for drainage, to make sure that the marsh sustains itself with sea level rise. When you look at this picture, I think I could also maybe point out that this marsh looks drier than this marsh. I mean, there's color radiation differences that are really depicting the wetness of the marsh and the species that are there. And this marsh is, because of the changes that have occurred, not only sea level rise, and I'll tell you that sea level rise is about 0.6 of a foot since I can't remember how many years now, but maybe even since the Corps' study in 1989, 0.6 of a foot. I might have written that. I can't remember all the facts. But anyway, if we restore that sheet flow, we could address the erosion that's occurring all along the marsh, because when they built the highway, they also built a linear ditch. They called it a temporary ditch. Why did they call it a temporary ditch? I don't know. And it was actually supposed to be paved. But they didn't pave it, and I don't know whether paving means asphalt, because that would be stupid, or, riprap, but it wasn't stabilized, and it's probably around twice the dimension as it was originally constructed because of the erosion. Now, if we do that, what are the benefits? Well, we would improve nursery and feeding habitat for fish, birds, and wildlife, improve sediment distribution for marsh accretion, which is important for resiliency. That's the next one. Improve control of invasive species, improve drainage for East Saugus, decrease erosion, and restore salt marsh intertidal and even some subtidal habitat. It's the largest restoration on the North Shore. Well, I guess some people might debate that what's going on in Great Marsh is bigger and better because it's a bigger marsh. But this is really a very important restoration to address the 444 acres altered by the embankment. I think it's the largest restoration and a very beneficial one. So suggested solutions. Well, people have been removing this fill as what's called permittee responsible mitigation. That's what they call it. That's where the Logan Airport, DCR, when they did the Nahant Causeway, it was Logan's inclined safety area project, boat ramps for airplanes, sort of, if you think of it that way. So those projects needed to mitigate the impacts, just like the Central Artery with the Spectacle Island fill had to mitigate environmental impacts. And people came to Rumney Marsh because it made sense. In fact, it's related. It's funny that when they built this, they were intending a third harbor tunnel at the time. And so when the third harbor tunnel came about, it was only reasonable to hold the DOT responsible for lands they altered, years previously. And it's possible for them to do it. It's relatively easy for them to do it because, at least at the time, they owned it. Now the DCR has ownership of the area. But it could also be used. There's something called in lieu fee mitigation nowadays. People are paying into funds. Instead of doing what's called permittee responsible mitigation, they simply pay into a state fund. And that state fund gets dispersed as people apply for the funding. But when the Saugus River Watershed Association applied for funding, they didn't get it. associated with the Ballard Street Salt Marsh Restoration Project, because the inland fee people really don't want to have anything to do with tide gates. Tide gates are problematic, So anyway, they didn't get a grant at the time. It could also be funded through, just continued use of beneficial fill. I mean, if DCR needed this material, let them take it out, because the more they take out, the easier it is to restore the marsh, in a sense. So that would be a good way to do it. That defrays the cost of doing the project, since it has value. The material has value. Anyway, and as you know, or if you didn't know, there's a lot of money coming to support resiliency funding, and people have to apply for the grants to do it proactively. And lastly, I wrote requirements for mitigation of new floodplain fill. Basically, there's some developments going on in the watershed. I remember one near General Electric, right? Is going to be a big housing project, but they had to add fill to the land to cover the pollution and to make it out, to get it out of the floodplain maybe. So people are filling, but they're not compensating for that fill right now, because it's believed that you can't displace the Atlantic Ocean by filling it. But if the Corps ever built the floodgate barrier project that they were intending at the mouth of the Saugus River, then the entire interior estuary becomes important for flood storage, and essentially the inland regulations of the Wetland Protection Act, which requires compensation for floodplain losses, would be applicable for this ocean environment. And that's true behind tide gates as well, that because there's limited storage of runoff, these areas should be more protected with requirements for compensation of floodplain storage. And if there was a requirement, this would probably have to be enacted through like a local bylaw. And maybe if somebody was allowed to raise the grade in their backyard because they're getting flooded, they would have to pay into a fund that gets used to remove a piece of I-95. So anyway, just a concept. I don't make things happen. I'm just an idea person. So with that, I'm going to say thank you and take questions.